Well, hi there. This is video number 8. Oh, I guess I need a pen if I'm going to write. All right, video number 8. And this is chapter 7, section 2. And this is all about sum and difference formulas. And here is your objective. And that is to use the sum and difference formulas for sine, cosine, tangent, cofunctions, and to verify identities. And we'll explain in a little bit what these sum and difference formulas actually are. But here's kind of a generic statement. So finding the exact values, which, by the way, generally means radicals, not decimals, of the sine, cosine, and tangent is often easier if we can rewrite the given angle in terms of two angles I need a little more space. In terms of two angles that we have known trig values for. Let me elaborate on that a little bit. All right, so you know all the sine, cosine, sine and cosine values for 30 degrees and its multiples. Right, 30, 60, 90, 120, 150, 180, keep going all the way around the circle, and 45 degrees and its multiples. So I'm going to just toss a picture of a unit circle in here. I might need to move it a little bit, but so we have this unit circle. We haven't talked about it in a little while because we've been talking about trig identities, but also recall for the unit circle that any ordered pair around the outside is cosine sine, right? So if I wanted, for let's say 135 degrees, I wanted the cosine, it'd be negative radical 2, the x value. And if I wanted the sine, it would be positive radical 2. So we know things about 30, 45, 60, 90, 120, 135, 150, so on and so forth. But we don't know things like 75 degrees or 105 degrees. But I can add and subtract some of the values on here to equal those numbers. For example, 75 degrees equals 45 plus 30. And you know things about 45 and you know things about 30. So if you could sum these two together, then you know things about 75. Okay, so that's kind of the idea of where this is taking you. So I'm going to give you the formulas for the sum and difference of sine, cosine, and tangent, and then we'll talk about how to use those. All right? And again, just recall your unit circle. You may want to tab that in your notes if you haven't used it in a while. It should be back a couple sections. I'm not exactly sure where we put it initially, but it might be handy to use that. All right, so I'm going to go to another screen. And here are your sum and difference formulas that you are going to want to have handy. I need to shim up my little notepad here. Formulas. All right. So we have the sine of alpha plus or minus beta. So remember, these are just two angle measures. So they could be, you might see them, a textbook I have says U and V. You could see theta and gamma. You could see all sorts of different things, A and B, whatever they are. They're just two angles. Now you'll see the plus and minus here. So what's going to happen when I put this into the formula, we're going to have equals, and it's going to expand out as sine of alpha, cosine of beta, and then plus or minus. So these match. If you're given a positive in the formula, you're going to match it to the top one. If you're given a minus, you're going to match it to the bottom one. I'll give you an example here in a minute. So this is going to be, the second half is cosine alpha, sine of beta. So I'll show you how you would expand this, and then we'll go to another one. So if you have something like sine of 45 minus 30, which would actually be 15 degrees, right? Then you could expand this out as sine of 45, cosine 30. And because I'm using a minus, which is the bottom one here, I'm going to use the bottom one here. These will literally match up. And now I'm going to go cosine of alpha, which is the first one. So minus cosine of alpha, sine of beta. And then you would plug values in. So looking at your unit circle, sine of 45 is rad 2 over 2. Cosine of 30 is rad 3 over 2. And you're multiplying. Minus cosine of 45 is the same as sine of 45. Rad 2 over 2. Sine of 30 is a half. So you would evaluate these. You'd multiply and you'd get rad 6 over 4 minus rad 2 over 4. And if the denominators are the same, you can go rad 6 minus rad 2 over 4. And that would be the exact value of the sine of 15 degrees. Okay? Because you could break 15 into 45 minus 30. So that's an idea of how you would use this. So the important part, well, there's a lot of important parts here. You need the actual formula. Let me get a highlighter. So formula, and then there's an example of how to use that formula. Now, if this was a plus sign here, then you would have a plus sign here. So these signs quite literally match when you do the sine formula. Okay? Let's go do the cosine formula. So cosine of alpha plus or minus beta expands into cosine alpha, cosine beta. Oops, that's not an alpha. Cosine alpha, cosine beta. Now these signs flip-flop, minus and plus. Sine alpha, sine beta. So let's do this. Let's go, here's an example of how we could use this. Let's go cosine of 60 minus 30. Okay, so now we're using the minus here, right on the bottom. So we're going to use the bottom sign here when we expand out. So we're going to go cosine of 60, cosine of 30, plus sine of 60, sine of 30. And you're going to see a lot of these are going to be really similar. So cosine of 60 is a half. Cosine of 30 is rad 3 over 2. Sine of 60 is rad 3 over 2, and sine of 30 is a half, so this ends up being rad 3 over 4 plus rad 3 over 4, which is 2 radical 3 over 4, and the 2 will cancel into the 4 and give you rad 3 over 2. And that would be the answer to that guy. Okay, so make sure that you use the opposite symbol of whatever you get in here because of how those are swapped in that formula. Okay, and then tangent is the last one. They don't have these for the reciprocal functions, so you only have to worry about sine, cosine, and tangent. We have tangent of alpha plus beta, plus or minus beta. And this guy's a fraction. You'll love it. So this is tangent alpha plus or minus tangent beta over 1 minus or plus tangent alpha tangent beta. Okay, so if we had something like, let's work this guy out. Let's say tangent of, well, I have these guys written down somewhere. Let's go tangent of 45 plus, I don't know, we'll go 60. All right, so let's say we need to know what these are first. And if we go back to our unit circle, let's pull this guy in here for a second, just so we can find these guys, because we need our tangent values, right? Hey, pop that in there. What's happening? Where'd it go? That was not effective. Okay, so remember that we have a couple of things happening here. I'm going to just lock this into place so I can write on it. Okay, remember that tangent is sine over cosine, right? So tangent is sine over cosine. So if we need 45 and 60, we need this guy and this guy. So, and also remember these are cosine comma sine. And if we're going to put sine over cosine, let's do 45 first. So tangent of 45. Sine over cosine, that means sine over cosine. Well, these are the same values. So rad 2 over 2 over rad 2 over 2. Anytime you have the same thing over itself, you always get a 1. So that's good. And then that one's easy. And then if we want to do 60, tangent of 60, well, the sine is rad 3 over 2, and the cosine is a half. And remember that whole keep, change, flip with fractions. So we're going to keep this the same, change this to multiply, flip this guy upside down. So we're going to have 2 over 1. Those will cancel, giving us rad 3. All right, so tangent of 60 is rad 3. Tangent of 45 is 1. Excuse me. All right, so let's expand this guy out. So we have, I'm going to write these up here. Should have brought something to drink while I made this video. All right, so let's expand it first. We're going to have tangent of 45, and we have a plus here, so that's the plus. So we're going to use the plus tangent of 60 over 1. Now the top one is going to be a minus tangent of 45 times tangent of 60. All right, so let's plug stuff in and see what we get. So I'll change some colors here. Tangent of 45 is 1 plus radical 3 over 1 minus 1 times radical 3. So we have 1 plus rad 3 and then 1 minus rad 3. And that would be your answer to that guy. All right, so that's an example of how you're going to use those things. Now, here is how you would use this if you're given a varsity question that looks like this. Find the exact value. Remember, that means radicals when you see the words exact value of the sine of 105, 105 degrees. All right, well, take a look at that unit circle. Here it comes again. And 105 would be somewhere in here, right? We don't know that value, but we do know some other things. So what you want to do is you want to use two angles that you do know. That will add or subtract to equal 105. And I can think of a couple right off the top of my head. So you could do, let's see, 135 minus 30 would equal 105. And you know those. There's 135 and there's 30. So you could plug those in. Or you could do 60 plus 45. That'll equal 105. And those guys are right here. So those are another option that you have. Either one of those. It doesn't matter if you want to use sine. So now we're going to find sine of 105. So here's an option. I'm going to go down here, extend my page, and we want sine of 105. So you could either do sine of 60 plus 45, or you could do sine of 135 minus 30. It doesn't matter which of these you use. Either one that you expand out will be okay. Okay? So I wanted to talk more about this part. I'm not going to go through just plugging them in. I think that we did that already. And you should be okay with how to do that. All right. The next thing I want to talk about, hang on, I got to shut a door. I don't know. We just walked in here. Well, we got some training going on and need it kind of quiet if you don't mind. Oh, where are you guys going? I was going to kick them all out. All right, just shut the door. Okay, that was weird. All sorts of people started walking in. Okay, so let's see. The next thing I saw in varsity was if you have like tangent of 11 pi over 12. Well, again, that is not a value on your unit circle. So the best thing for you to probably do is determine where this is in degrees. Okay, so remember to do that. You're going to take 11 pi over 12 and multiply by 180 over pi. Cancel your pi's. I stuck this into Desmos and I got 165 degrees. So how are you going to get to 165? Well, the thing that stood out to me was 135 plus 30. And so if you need tangent, you're now going to go tangent of 135 plus 30, and you're going to expand that out. So you would use tangent of 135 plus tangent of 30 over 1 minus tangent 135, and this is multiplied, times tangent 30. And then you'd finish that out from there, okay? Another problem you're going to see in varsity is going to look like this. Given sine 3x cosine 4x plus cosine 3x, I need an eraser. I need a black pen. Okay, cosine 3x sine 4x. It says, oh, that is not straight at all. Write the expression as a single trig function. And so here's what that means. That means you need to find which trig function, the sum or difference that's going to fit into. Well, note here how this looks. So we have sine cosine plus cosine sine. Okay, sine cosine plus cosine sine. So I'm going to go back to the beginning where I started writing these guys down. Let's see where I put these. Let's see. Sine cosine plus cosine sine. So this is a sine alpha plus beta. That's exactly what you're looking for. So that fits into this equation. So this fits sine alpha plus beta. And so what you have is sine 3x plus 4x, which is sine of 7x. And this is the answer that you would plug into Varsity. So they're looking to see if you can go backwards. Given the expanded form, right, that's what this is, the expanded form. Can you figure out which actual function you need, sum or difference, sine, cosine, or tangent, put them in the right area, and then just combine it, okay? So that's how that's working out. Here's another example that looks similar to that. Given cosine 15, cosine 75, minus sine 15, sine 75, write the expression as a single trig function, and evaluate. Okay, so we're going cosine, cosine, minus sine, sine. Well, that's one of the cosine ones. So what I'm looking at here is just the generic form of this thing. I'm going cosine, cosine, minus sine, sine. So I'm going to flip back, and that's my sines. Here's my cosine. So cosine, cosine, minus sine, sine means I'm actually looking at cosine alpha plus beta is the one with the minus in it, right? So cosine alpha plus beta. So let's go back here. Get a pen. And we're looking at cosine alpha plus beta. In this case, my alpha and beta are these two values, which means I'm looking at cosine of 90. And you guys should remember that that's a quadrant angle. Right here, the ordered pair is 0, 1. Cosine is the x value. And so cosine of 90 equals 0. And that is what that would evaluate to, and you would answer. Okay? So that's the end of 7.2. Hopefully that goes okay. These aren't terribly difficult. Don't overthink them. They're not terrifically hard. Also, if you need to, you could go back, and if it helps you to separate these, like you could write these this way. Like some of you, I don't know if you'll need to do this, but sine alpha plus beta, sine alpha minus beta. You could write these out separately, right? This is sine of alpha cosine beta plus cosine alpha sine beta. And then you have sine alpha cosine beta minus cosine alpha sine beta. Like if you need to do that for yourself and separate these, you could have 2 for sine, 2 for cosine, 2 for tangent. So I would make these all a list somewhere. I made them separately and did examples separately, but I would put them all in the same place somewhere in your notes. Sine, cosine, tangent, all 6 in the same place, so you know exactly what you're looking at. All right? Okie doke, 7.2, toodaloo.